Hello everyone, I'm Nick and today I'm gonna talk about Reason React, especially a new version that has been shipped. Just a brief couple of words about myself. You can find me on Twitter. I like things like GraphQL, Reason, and basically my background is web development. A couple of years ago I dabbled a little bit with Dart. That was interesting because it was this. It has an optional type system way before TypeScript or Flow was a thing. So that's where my background is, building user interfaces in a web environment. And about 2.5 years ago, a friend of mine, Patrick, who spoke here last time, he actually reached out to me, or like we were trying Reason out a couple of months already, and we kind of liked where it's going, and we thought about organizing. We organized a meetup in Vienna. It was actually the very first Reason meetup, and then we thought about maybe we can do a conference. So. We actually organized ReasonConf last year. It was I organized meetups, the React meetup in Vienna for 2-3 years. So that was a brand new experience organizing a conference. But it worked well. We had like 170 people from all over, like web developers who like 50% probably were web developers who have touched Reason. And then there were like a couple of OCaml people, some people that were experienced with Reason. It was quite interesting. And this year, a month ago, we did the second edition. And this was very different already because you see companies with like 20, 30 people actually shipping larger applications written in Reason and OCaml in production. And that was quite exciting to see. And this year we were like above 200 people. So you see that it's steadily growing and it's actually pretty exciting. The very first year we did it on my personal company. That was a bad idea. Tax advisors and tax stuff is complicated then. What we did before this conference this year, we have founded the Reason Association, which is basically an association, an organization to fund community projects that are related to Reason and embrace the OCaml technical foundation. And like the very first thing that we focus on at the moment is ODoc. So we have a couple of PRs that make improvements to ODoc, and the biggest one was basically adding Reason support to it, obviously. But then we can see. The idea is to like continue like having Reason and OCaml leverage its benefits from both sides, and we're gonna add more projects. But we also like it's a little bit of a chicken and egg problem. You look for funding to fund projects, then you fund projects, then you get more funding. So we're ramping this up slowly, and it's working. At least better than expected for me. Yeah, and today I want to tell you a little bit about Reason. So we have seen that part. And let's get right into like React, because that's the basis of it, the core of it. If you talk about Reason React, who of you knows what React is? Okay, a couple of people, that's fine. Who of you, of these people who knows it, like has used React? Okay, 1 or 2, 3, interesting. Then this is very good. But to give you an insight, like what my personal history is, I worked with various web frameworks like jQuery 10 years ago, and then Backbone.js. These were like very imperative coding, and you basically relied on keeping references of JavaScript objects. Otherwise, if you disconnect from them, it's like you basically lose connection to the UI that is actually rendered on the DOM in the browser. And to me, React was the entrance to functional programming in a sense that I could use immutable data structures because you could simply, with React, you can pass in like, if it has the same structure, you can simply drop it in and React will not cause a re-render in the DOM. And this is really, really important because no other framework before this concept of a virtual DOM, nobody ever did this. Like in game software, in game development, this concept existed since quite a while, but for browser engines or browser frameworks, this wasn't there and nobody did before. And Jordan Walk, he actually he wrote the very first version of React in standard ML. And then it was ported back to JavaScript for the Facebook code base to be usable there. And React itself is basically a JavaScript library for building user interfaces. The very first version was just rendering, kind of like templating, and you can throw in data, and basically if there's no new data, it doesn't re-render. But nowadays it also includes state and effect management. Let's get right into it and actually show how we can render something and what it means. So the very first thing you need is, I probably do the demo mode right away. Let's do this one here. Here, if we remove, let's go back here. I have an index.html. It's pretty straightforward. Just a body with a div with an ID root. And then I have my compiled index.js output. We basically use two tools here to generate this index.js. Let me show you. So for once, we use BuckleScript, which is a compiler to compile OCaml or Reason code to JavaScript. And then we use a packager, JavaScript packaging tool called Webpack to actually compile it to like bundle it together to have different modules bundled into one JavaScript file. And if I do now a simple example, what I can do here is in my index.re, let's simplify this. I could, let's make it a little bit smaller. I could say, render me an app module, which is JSX. I explain that in a second. Basically into this root ID. And then I could create a Reason React component. Let's make a very simple one. And this would be my simply rendering an h1 tag into with hello in there. And what you can see now is there's basically a hello. So what you can see here is we have our div root, and then basically with React we tell it here render this element, this component, this React component into our DOM. All right. And then you can see here we have our h1 with hello. So basically we have a lot of like, I mean this might look very crazy to you because we have a lot of like magic and overhead to have just a simple templating language to put in HTML. But there's more to it, I promise. So what's happening here is that we basically, let me explain it a bit. First of all, this is just a module, and it has a couple of functions, but one is like render to the specific ID, and then we do app. And there is a lot of magic already going on because this is JSX. This is like an invention that happened with the very first React version. It's basically it's an HTML-like syntax but under the hood it compiles. If you have like it compiles to React.create element. And then you have multiple arguments and so on and so forth. But one thing that we can, for example, look at is the output. There you can see it basically. You have React.create element, and then you basically call this other module, and we don't pass in any properties, but we render it in there. Yeah. So what we can do now is, and basically here you have a component. This is a very simple one. Where does this come from? This is a PPX. Basically converting this make function to be to return a type JS of t, which is part of the Buckle script environment. And at the moment there is basically nothing. Like it creates then this component, and then you can leverage this. What we can do now is we can, for example, say hello and provide name, labeled parameter, and use this in here. Name, we concatenate simply. And what will happen here is now that this transforms it to a properties object, because in React, in the JavaScript world, you actually, React expects that you pass in a full object and not labeled arguments, because in JavaScript we don't have labeled arguments. But OCaml and Reason have this awesome feature of labeled arguments, so we're going to leverage it, and we are this PPX, we basically transform it to a JavaScript object. And you can see this here. Actually what comes in here is an object, a JavaScript object, and then we can get out the name, and we can use this React.create element to actually return the React element. And the outcome is not a hello undefined. That's bad. What's happening? Oh yeah, of course. So actually the compiler will not fail, because as you can see, it expects something else at the moment, and that's the case because in app now we don't pass in the name. But now since it's mandatory for this function, for the make function, you need to also pass it in where you use it. And how you can do this is say, for example, hello Paris. The name is Paris, and what you get out is then hello Paris. So basically, all the properties on this HTML-like syntax, the JSX syntax, get automatically converted to labeled arguments. That was that demo, and I mean, this is probably not too relevant for you, since most of you don't know React too much, but React currently is undergoing massive changes. Like it was class-based, or like to manage state. And to manage like lifecycle events, like for example, I want to get the real DOM node out for after the component actually has been rendered to the DOM. Sometimes this is useful to, for example, measure the height of the actual DOM node in the browser. If you want to do certain like visual scrolling, or if you want to do an auto-scrolling text area, you need to have access to the real DOM. You had so-called lifecycle hooks. And currently, the React core team basically tried to figure out a new way of like still have only functions, but basically give a way to manage state and manage effects. And this new concept, they gave it the name hooks, and I'm going to show you that in a second. And that is basically done. But there's more coming that loops into this whole ecosystem of React that is like that is basically like one of them is suspense, where you can give tell, like if you render a tree of components, you can basically tell it like at this point the tree is not ready yet, so wait until I'm actually ready, and this can trickle up the render tree, and you can basically suspend or have like a loading indicator for nested things in there. Don't worry about that too much, but there's like also time slicing, which basically allows you to like give different work priorities, different priorities. That's completely early stage, but it's very important to do things like, since we have like with JavaScript, same as with OCaml at the moment, we have only like one main thread. Work that it's blocking each other can be really problematic. So for example, if you have like, if you do a request, but you also do like animation work, you don't want the request can wait for a little bit longer until the animation is done, but you actually, you want to make sure that the animation runs smooth, because this has a large impact of the user experience. You know, if you see something, if you go to a website or UI, and like the UI is stocking because something is happening in the background, this is really annoying. And these are the things that the React team is basically really trying to focus hard on, to like give good developer experience. I mean, you could also always code this in imperative code, and like, but they want to build basically this framework to make it easy to deal with these situations. Yeah. So a lot of it is like undergoing a lot of changes, but what we have already is kind of like one tool to have greater developer experience. This is the like super new sexy thing in React. They call it hooks. So let's see what we can do with these hooks. We can one of them is like manage state. So I'm gonna use this one and put it right into code here. So we don't get any property anymore, so we can remove this here. By the way, you can nest components, but I will show you that in a second. I think I haven't mentioned that. But in the end, like it's very similar. We have our ppx React component. We have our make function, and then we basically have this JSX tree that we pass in here. It's like, in the end, it's just like a bunch of like nested React elements. But what we can do here is we can basically get this small application that is a counter that you can click. And we have a div here. We have a paragraph. This makes it a bit more readable. We have a div here. We have a paragraph. Then we can indicate like how often the count has been, like the counter, what it is, how many times it has been clicked, and then we have a button with an on-click event, and we can update it. So what's happening here is, on the very first render, we have this thing called React, or like this hook called React.useState, and it you have to pass it in a function and basically return the initial state. So on the very first render, when this happens, when make is invoked, it will run this function and it will return a tuple of count and set count. Why a tuple? It's kind of crazy, because then you can leverage this and you can use this multiple times, and you can say something like this. You can, by actually returning a tuple, you can provide your own naming to it. Obviously, then for a name I want to have a string, max or something. And then it will take this initial count, so the initial count will be 0, and it will basically just render out what it has. And this is the result. We get here our div with then the paragraph and the button with click me. What's happening here now, if we actually click the button, it will invoke, like there's a callback on the on-click event handler that gets an event, basically the click event, and then we can update the count. The count, let's make it, we're shadowing here, so we can do current count to make it a little bit more obvious. But we basically set count also accepts a function giving you the current count, and then you can do something with that state, manipulate it, and like you basically, the return value will be your new state. And this is exactly what's happening. Then, because this is coming from the React core, it knows that you invoked set count, and it knows exactly based on that which function or which component it has to re-render. And then it can re-render the whole tree below this component again. And so what's happening is that if we click once and click twice, we basically increase the count. So this is a way to basically encapsulate state locally inside a component. And if you think about building forms or something that has like local state, this is a really, really handy tool. The ergonomics are really easy because you can encapsulate state management inside one UI element. You probably have a lot of questions, or it looks really weird, and it is indeed. There are a couple of problems with it, but yeah, if you want to ask them, or okay. Maybe I continue a little bit, and then we can answer more questions. Yeah. But yeah, keep that in mind, and then we can talk about. The one thing that's interesting about this concept is the more I use it, I actually really enjoy the ergonomics, the development ergonomics, because it's really it's easy and nice and very quick to ramp up new user interfaces. One thing that I like, useState is useful for very, very simple state situations. But one thing, like we have variants, so we actually want to leverage them. So there's in the React core another thing called useReducer. And this basically allows us to have like one single state that obviously then can be a record or nested variants of records or whatever. But it allows us to have like this idea of a reducer, that like you have a current state plus an action results in a new state. And basically, if you look at this app, how I changed it, I have now my increment, but I can also reset. So I have two different buttons. And here I'm showing the counter state and then the increment and the reset. But I want to have two different actions. And I'm using a variant here because this is obviously the best data structure for this. So I can have an increment and a reset. And then I can have this useReducer, which again returns a tuple of the current state, and then the send function, which accepts an action. And then I have, as the first argument or parameter of useReducer, I basically need to pass in a reducer function, which gets the current state. Let's actually change this again. Current state, and then the action, and then I can pattern match on the switch expression. Switch is basically what matches in OCaml. I can pattern match on that, and I can, based on the action, I can basically define what my next state should be. So I have the current state, it can do +1, or I can set it to 0 right away. And the second parameter argument of useReducer is basically the initial state. And So basically, when you do more complex state management inside, like locally inside a component, you could use reducer because it's way nicer and handier to handle it and deal with it. Obviously, I can do things like value. I can do things like this, increment by 1, and like a second button that increments by 2. And you see, this is how you quickly ramp up different UI elements with this and manipulate state. Another thing, so this is use reducer. Another thing is use effect. So one thing I can do here is basically I could combine use state with an effect, and effect is basically something by default it will run every time. It's like a callback. You can pass in a callback every time the component renders. I want to invoke this callback. And in this case, I can use direct bindings to JavaScript to set an interval that increases always by 1, and then this interval will update set time. So every second, we're basically increasing the counter, and we start re-trigger a re-render. What we need to return is a sum of, or you can also return none, but basically a cleanup function. So it's a really weird thing because you basically use effect. You have a callback, where you can set up something that should run. But if you want to, once the component gets removed from the DOM, unmounted because the tree changes, you obviously, if you like set up a timer, you want to set an interval, you want to clean it up as well. And this is you basically can return, this is what gets returned from the use effect. Either an option with the cleanup or none. Then what you can do, you can pass in another argument, and you can basically limit which of the effects, based on which properties the effect should run, and so on and so forth. But don't want to go into that. I think this is already crazy enough. But basically, this is how you can suddenly like encapsulate like kind of effect management with state management inside a component locally, and it allows you to do things and build whole applications that just consists of components of components of components that are nested, and basically build your whole applications based on that. Yeah. Cool. How about one thing that that I have shown is what if you would put a use state or something in a conditional, or if you loop over it. This is actually a real problem. So this is where we trade ergonomics for safety. This is a real problem also in the React.js version. That let's say if you have two use state, and you have a name and set name, and you have here max. If you put this in a conditional, and like in one render, the one would be before the other, and the other one before after the other one, you flip it in two different renders. There's no way of React to determine which use state belongs to which initial state. So you would actually completely break the system because you get different things you get different state in different renders at different with different expectations, and this is a real problem in like the way it's implemented at the moment. And the only way we deal with it in JavaScript is basically we have a linter that makes sure you never put any hook into a conditional or into a loop. Basically, the linter would scream at you if you do this. It will tell you don't do this because you probably will screw up. And this is kind of scary. This is fixable in a way that basically, in the end, like use state is simply basically putting itself onto a slot. A slot, like a stack of like stack of. It's like a stack. A stack. You like use state is like the first one puts it on a stack there, and then the second one would put it there, and there are in JavaScript it's not possible, but in the in Brisk or Reverie, which is like a native implementation of the React idea, we have some of the creators here. You actually can make sure that a component would get this stack, and then you can use the pass in the stack always, and there you can with type safety you can ensure. With the type system, you can ensure that the right call always gets on the right position in the stack. Otherwise, the type system would complain that this is not correct. And there's other ways you could, even some people wrote for a different implementation. Like since hooks are out in React, a lot of people are experimenting a lot with like, how can we make this type safe? And one would be you could make a PPX. That would make this type safe, and if you flip the order, it would simply scream at you and tell you, "Hey, this is not what I expect from you." But yeah, this is kind of interesting. Why does the React Reason React version? I mean, we could simply put this into the core. A couple more minutes? Okay, perfect. I'm getting to the end. Why do we match the API exactly and not build the PPX like right into it? Because we anyway have React.component, and it's like a lot of magic happening there. The current version tries to match a zero overhead policy to like the previous Reason React version was a had like basically shipped with a small runtime, and like every compilation, every time you compile the Reason React component, there was like intrinsic code that was generated, JavaScript code generated to actually make React.js components comply, like either work with Reason React components or Reason React components work with React.js components. But in a world where, at least where I come from, we have a lot of existing React.js components, and you don't rewrite your whole multi-thousand lines web application in one night to Reason React. You actually want to go for an incremental adoption. You want to basically say like, cool, I have my larger application, but this is a part that is really buggy. And we care about it, we want to improve it, then you can basically drop in Reason React, you put the compiler in there, and if you can use React.js components and Reason React components interchangeable, but just passing in, like using them and passing in the props between them, it's really, really handy to like adopt incrementally. How does this look like? I have here, I mean, this is the basically this one. No, not this one. Did I close it? I will code. I will show you here. So basically, if I have, for example, bindings to an existing, I can do with BuckleScript, I can do bindings to an existing React component. This would come from the React leaflet module. I could simply say like, the make function basically, it's basically a kind of foreign function interface maps to, like, I get these properties and they get directly, it maps to this map object of React leaflet. And what I mean with zero or runtime overhead, like just by creating the bindings, you don't, like the actual JavaScript output is zero. You basically add type safety to it, but without adding any overhead, every JavaScript overhead. Yeah, because a lot of JavaScript people are very sensible to like bundle size and so on. The more you ship, the more the slower loading times get, and so on and so forth. And before I wrap up, I want to show you one really cool thing. You have these hooks, but then if you can basically create your own hooks, which you just like if you use one hook inside another hook, like it's just a function. A hook is just a function in the end. In the end, you're gonna use something that lets React know you wanna update the state or something like that, and you can basically start to create your own hooks, and this is really useful. And let's go back here to the initial thing. Yeah, and here. You can do things like data loading. Who of you has heard of about GraphQL? Okay, a handful of people. For the ones who didn't, it's basically a query language that allows you to fetch data from a service with a predefined protocol. So if I do this here, you see I get a request, there's a query, then there's like this query that I want to fetch, and I want to get the restaurants, and of the restaurants I want to get the name and the ID, and then you can even pass variables to like make things more dynamic. And then I get back a response which includes data, the restaurants, actual JSON. And this is how I can fetch data. And the good thing about GraphQL, it's a typed schema. And with a GraphQL PPX, and this is, at least from my perspective, really cool, I could simply get type my query here, use the PPX. I can generate this hook, use this hook, and then get a variant to actually have inside a component. Either I'm loading, I'm getting an error, or I'm getting the actual data, and then can, with this object syntax, map over it and basically render these two restaurants. And what I really like about this, the whole PPX idea here is that, first of all, the PPX, if I want to query something that is not available in the schema, like I do something here, first of all, the PPX already can tell me, hey, you try to fetch an unknown field, or if you have a mutation, you try to pass in an argument that doesn't exist. So on one hand, the PPX already does validation for the schema, which is really handy, especially if you use with the APIs that you haven't built. And the other thing is, like, obviously when you, not obviously, but the PPX returns as a result, and then the response is actually typed. So if I try to, for example, access the name of the response, it's well typed. And if you compare that to JavaScript, TypeScript, or Flow, this is not the default. You need to do a lot of work. You need to run you basically need to manually generate the types, import them, and import the type and pass them into generics all manually all the time to get type safety. And this is kind of this is something that Reason and OCaml can do for us in terms of developer experience that I haven't seen in any other ecosystem for front-end development yet. And this is something that makes me and a couple of people in the React community really excited about Reason and OCaml. And the very last thing, some thoughts, at least from my side, as someone coming from JavaScript. What are the pros and cons of why using Reason React, or why using React in general? Obviously, you have to use Buckle script. if you want to use JS of OCaml, you probably have to do a lot of groundwork by yourself. And PackerScript, not everyone is a big fan of PackerScript because it does a lot and it has a lot of magic, and it's like the buzz factor is very high. There's like 1 to 2 people actually like building and owning it, and that's kind of dangerous. And you basically need to maintain all these bindings. But the huge benefit is if you can leverage the whole React ecosystem, and they build everything. Everything that you can imagine that you want as kind of a UI component with a certain user experience, it's out there. Sometimes you don't want it, but then you could simply, it's open source, you can take it, you can fork it, and you can basically create bindings on top of it, or you can get inspired to build a type-safe version of it. I hope this was, I know for someone not familiar with React, this was like very interesting, different approach, but I hope this was an insight to what we do from the Reason community and what we're aiming for. We basically want to build great user experiences, and having a type-safe system to do that helps us to really avoid a lot of bugs and create a better developer experience, and that's why we do this. Thank you very much.